Okay, let's look at a few of the things we can do with vectors. So we're going to look at some operations, and we're only going to look at two operations in this video, which are addition and subtraction, which is very similar to addition, and multiplication. Okay, so vector addition. So when you're adding two vectors, right? So let's look at it graphically first. What we have is, yeah, let's say we have, that's A. I'm gonna make B here. Right, there's two vectors. Actually, I will, yeah, I'll draw it a bit separate here, right? So let's say we want to find A plus B. So the first thing we need to do is bring A and B together, head to tail. Okay, so they always go head to tail. So unfortunately, in the program I'm using, I can't sort of select this and move it up. But if you can imagine just picking up this B vector and placing it right next to here. So I'm gonna draw that here, right? Oops, it's a bit wonky. There you go. That's the same vector. It has the same direction and the same length. And I'll just erase this one. Okay. So once they're head to tail, then it's really easy to add them. You just start from the tail of the first one and go to the head of the last one, right? So this is A plus B. Okay, so I said head to tail. What if I had taken this up and attached this head to this tail instead? Well, it turns out you would get the same vector, so it doesn't matter. You would get the same answer, right? So I'll try to draw them the same. So that's A. And let's say this is B, right? So then A plus B, or here we're doing B plus A, which is the same as A plus B, would be there, right? So A plus B. And you can see from comparing this and that they have the same direction and the same magnitude, right? Obviously my diagram is a bit rough, but if you were to use a ruler and perhaps measure the angles, that would be the same. So this is the geometric way, or the graphical way, of representing vector addition. And subtraction is the same thing, except, you know, you can think of subtraction as just, so if you had to, this is A plus B, if you had to do A minus B, the B would just be, this would be facing in the other direction, right? That's minus B. That's because the minus out here just changes the direction. Anyway, let us look at the algebraic representation of addition. So what I will do is, I'll rub this one out just to make some space. Okay, let's say that A is equal to 4i plus 7j, right? So it goes 4 right and then 7 up. This one, B, could be perhaps 6i and 5j, right? And adding vectors is very simple. All you do is add the individual I components and the j components. So we're going to add the i's together, right? And the j's together, right? So you can really just do this in one step, but just to illustrate it and to make sure you guys aren't missing anything, I'm just going to write it all out. So A plus B is 4i plus 7j plus 6i plus 5j. So I've just written in the values of A and B. Next thing you would do is collect the like terms. So you've got so bring the i's together and the j's together. So this becomes 4i plus 6i plus 7j plus 5j, and then it's really simple. You just add the I components together. That becomes 10i plus 12j. So you add the I components and the j components separately. And that's it. And maybe you could call this another vector. You could maybe call this C. Yeah, but you don't have to do that. So the algebraic sort of representation of this is just that. And just remember that you can, like I said before, this can be in another notation, which is 4, 7. This could be 6, 5. In that case, if you were adding them together, it would just be 4, 7 plus 6, 5, which gives you 10, 12, right? And that's the I component, that's the J component, just like you have here. Okay, let's do, there's one more thing I wanted to get through, which is scalar multiplication. I'm just going to go through that really quickly because that will not take long. Actually, what will take long is me rubbing all that out. So these were some questions that I had, but I will go through them in a different video, just so the video doesn't go too long. Okay, so scalar multiplication. Right, so what that means is you're multiplying a vector by a scalar. And that's really simple, like this will only take a minute to explain. So you have a vector, let's say that's A, right? And but if, actually I'll make it a little bit smaller so that everything fits. A, let's say you wanted to find 2A. What's 2A? 2A is just A multiplied by 2. Now 2 is a scalar, right? Because it's just a number 2. It doesn't have any direction associated with it. That's why it's called scalar multiplication. So 2A would just be there. 2A. You literally just multiply the length by 2. So scalar multiplication only changes the length, right? And if you were to look at this algebraically, it's just as simple. For example, let's say that A was equal to 2I plus 3J. So what's 2A? Well, you just multiply, in fact I will do this in red. So you just multiply the I component by 2 and the J component by 2. So this becomes, so I'm just gonna write it out like this. So 2 times 2I plus 2 times 3J. Again, I'm doing this a long way, but you really don't need to do that. You can really just do it in a single step because it's so quick to do. Right, so that's 2A. And same goes with whether you have fractions in front or surds. You could multiply by a scalar that's negative. In that case, you would change the direction, right? For example, negative 3A would be, so negative 6I minus 9J. And that would be 3 times the length, but in the opposite direction because of that negative. And I'm not going to have space to fit that on the screen, but you can imagine it would go, over there somewhere. That would be negative 3A. Okay, in the next video, we'll look at those 2 examples that I had above.